Welcome to ASA, which is part of Think Tank Online Learning. So you solve unsolvable questions. Okay, we solve difficult questions, right? Okay, so right here we have a limit problem, right? So this one is not variable calculus, right? Okay, so right here we have x to the power 3 plus xy plus y squared, or divided by 2 minus the square root of x squared plus xy plus y squared plus 4 under the square root, right? And want to evaluate the limit at the point where x is 0, y is 0, and z is 0, right? Okay, so what we're going to do, right? Okay, so first of all, we're going to start by plugging in 0 and see what will happen. Okay, so let's do that. We're going to plug in 0. For x it's going to be 0, for y it's going to be 0, for y squared it's going to be 0, right? Okay, so now let's simplify. So on the numerator we're going to have 0, on the denominator we're going to have 2 minus 0 plus 0 plus 0 plus 4, we're going to have root 4, right? So we now have 0 over 2 minus 2, because the square root of 4 is 2, right? Okay, and this will give us 0 over 0, okay, and this is undefined. So we have a problem. Actually, we have a big problem. So what we're going to do, we're going to change our technique, right? We're going to reason, right, with this problem. Okay, so now what we're going to do, okay, so someone may think of polar coordinates, right? Letting x because r cos theta and y because r sin theta. But we have 4, right? And we're not going to win because we're going to be left with r, right? And we're not going to win, so that formula is not going to work, right? And someone may think of rationalizing the denominator, and we're not going to win either, right? So what are we going to do? Okay, so we're going to change the appearance of this problem, right? We're just going to change the appearance, but the value is going to look the same, right? So some of you may be confused what is changing of appearance. Okay, it's the formula that we're going to use, right? So let's say we have 4, right? And I'm going to say 4 equals to 4. Okay, this doesn't make sense, right? But the reason why I'm doing it is because I want to say 4 plus 2 minus 2. So right here, 4 plus 2 minus 2, you can see plus 2 minus 2 give us 0, and so here 4, right? But what is the difference between the first line and the second line, right? It's just the same. It's only a matter of appearance, right? But the value is still the same, right? So let's put 4 plus 9 minus 9, and still here 4, right? Okay, so that's what we want to do. We want to twist this problem, right? But we want to maintain its value. Okay, so with that technique you can kill it, right? Okay, so how are we going to do it? You have to look at the question that you're given, and in every question there's a weak point, right? There's a clue, right? Okay, so now let's look at the numerator. Okay, this is what we have. Okay, let's take a closer look, right? And let's look at the denominator, right? As you can see, we have what we have on the numerator, right? But it's a little bit different. We have a square root right here, and we have 4, right? And we have 4 right here, and we have 2, right? And we have negative sign. Okay, so that's what we have. Okay, so you can see there's a relationship, right? You can see we have 2 and 4. There's a relationship somewhere there, right? On the numerator, it's what we have on the denominator, but it's squared, right? There's a square root, and we have that sign. Okay, so now we're going to change the appearance of this problem, right? So let's say we have root a right here. Okay, so that is what we have on the denominator, right? As you can see, we have it right here. Okay, so and here we're going to have a. Okay, so what is the relationship, right? What is the relationship between those two letters, right? So I'm just assuming whatever on the numerator is a, and whatever on the denominator is root a, right? As you can see. Okay, so if we think deeper, right, you can see that we can write a is the square root of a squared. Okay, because if you look right here, we're going to have root a times root a, and that one is going to give us a. Okay, so now we have a clue. So want to use this technique, right? We have to take advantage of the square root. Okay, so that means we're going to change the appearance of the numerator or the appearance of the denominator, or just want to equate something, right? So that we can be left with, let's say, 2 over 2, 3 over 3, so that we can divide. Okay, so now let's look at our numerator. I want to write something with the square root, right? Okay, so you can agree that this is equal to this, right? Because if you square, we're going to be left with what is inside the square root, right? But that's not what you want. What we need to write this on the numerator, right? That's what we need to write. So we're going to put plus 4 right there. Okay, so this is what we have, right? This one should not be equal to this one, right? As you can see, we don't have a 4 right here, so we don't have a 4. So what are we going to do? So that means if we square this one, right, we're going to be left with this one. Okay, but we're going to be left with 4, right? We have excess 4 right here, which is going to be plus 4. So now we have to subtract it, so I'm going to write minus 4. So now it's now good. You can now agree that this one is equal to this one. If we simplify here, we're going to be left with what is inside the square root. okay? And we're going to be left with the plus 4, right? So if you say minus 4, it's just going to be the same with this one, okay? So now we have a clue, okay? So that means let's write our problem, right? So instead of writing this numerator right here, you can see we have replaced with this one. So just the same, we've changed the appearance, but the value is still the same. Okay, and right here, as a mathematician, there's something you should see. So you have 4 here, and you have 2 right here, and something should click in your head, right? So what is the relationship between 2 and 4? So we know 2 squared is equal to 4. Right. We are winning. So let's move forward. We're going to write 4 as 2 squared. Okay, so we have something right here. And in mathematics, so you have to use what we know. So what we know, this is what we have. Okay, so as you can see, we have this squared right here, and we have this squared right here. Okay, so what can we think of? Let's think of the difference of 2 squares. Yes, difference of 2 squares. Should be familiar with this one, right? As you can see, so now if you look at the numerator, right, we can see this one, we can name it a squared, and we can name this one b squared. Okay, so let's say our a squared is got the first part, and our b squared is got the second part. Okay, so now let's factorize the numerator. Okay, so you can see we said a minus b, so we said this one is a, right, and 2 is b, right? And here we have a and we have b, and somewhere it's going to be negative, and right here it's going to be positive. So let's rewrite our problem. Okay, so this is what we have. Okay, but something is not good right here. What we have on the numerator is not what we have on the denominator. Okay, so we have a problem. As you can see right here, we have plus 2 and you have plus 2. Okay, that's good. But right here you can see we don't have a sign right, so that means we have a positive right here, but here we have a negative. Something is bad right here. Okay, and right here this one is positive, right? And this one is negative. This one is negative and this one is positive. Okay, something is not good. Okay, our problem is not arranged, right? So let's change its appearance, right? So we're going to change its appearance, right? So as you can see right here we have a negative 2, but here we have a positive 2, right? So how to make a positive a negative? Okay, so as you can see we have a clue right here. So right here it's plus, but here it's negative, right? And right here it's plus, and right here you can see it's negative. So how to make positive 2 negative 2 without affecting its value, right? So you can see right here we have 2. So if we put a negative and a negative, this one is going to give us a plus, and this 2 here for 2. Okay, that is good. So that's what we're going to do right here. Okay, so now we have 2 right here. As you can see, this one is plus 2, right? So if we say negative and negative, I can get plus 2. Okay, and right here I have a negative right here, but right now I have a positive. But if I multiply this positive by this negative, I'm still going to get the negative. So I've changed the appearance, but the value is still the same, right? So it's now time to arrange our problem, right? As you can see, I'm starting by writing the positive one, which is this one, which I've written right here, and I'm going to end with this negative one, right? But remember, my minus right here is still there, which is this one. So writing our problem right here, this is what we have. Okay, and we have something that looks familiar, right? You can see this is similar to this. Okay, I'm just going to highlight it. Okay, so this is what we have. Okay, and now this is a bracket, right? So that means there's a times right here. Okay, that means you can just divide this one by this one. Okay, like this, and we're going to be left with the negative 1 at the denominator. Okay, and as you can see now, you can substitute because we no longer have 0 at the denominator. Because if we have 0 at the denominator, that means the function will be undefined, right? Okay, so now let's substitute. Okay, so for x it's going to be 0, for y it's going to be 0, for z don't have z, but we're told that z is 0, and we're going to have plus 4 plus 2 divided by negative 1. Okay, so right here, if we simplify 0 plus 0 plus 0 plus 4, it's going to be root 4 plus 2 divided by negative 1. And we know square root of 4 is going to be 2. 2 plus 2 divided by negative 1. If we divide 4 by negative 1, we're going to get negative 4. And this one is going to be the answer. Okay, so as you can see, it was tricky, but we managed to do it. And by now, I hope you've subscribed. If you haven't subscribed, I don't know how to convince you, right?